Hello again. It is time to go through these questions on simultaneous equations with an elimination method. If you haven't had a go at these yet, then pause the video, give them a go. It makes a much more difference if you try them, even if you can't do them, if you try them first, and then we go through them. If you just let me go through the answers, you're really not revising anything. So come on, pause the video and give them a go. Well, hopefully you've paused by now, you've done the questions. Let's see if you got them right. The first one is nice and easy because I can cancel the three y's. They're both the same. They're both 3y. Okay, so I don't need to multiply up the equations before we get started. They're both 3y, and the signs are the same. They're both subtract. They're both negative. The signs are the same. You subtract. So I do 5x subtract x gives me 4x, and I get, now this is where writing subtracting would be helpful. Okay, I didn't need it for that, but look, 8 subtract minus 2. It's so common to see people subtracting the equations, but doing 8 subtract minus 2 and kind of blurring the two subtracts together. And they just do, 8 minus 2 is 6. It doesn't work, okay? So be very, very, very careful with those negatives. 8 minus minus 2 gives me 8 plus 2, which is 10, so x is therefore 2.5. And if we put that back in, I'm going to put it into the easier one, I'm going to put it into that one, and we're going to get that 2.5 minus something is minus 2, so let's write this out. So 2.5 minus 3y equals minus 2, so this is positive 2.5, so let's take it away, so we get minus 3y is minus 4.5, and if we divide minus 4.5 by minus 3, then the minuses are going to cancel, and a third of 4.5 is 1.5. So we get that y is 1.5. So let me write the answer up here, just where there's a bit more space. The x answer was 2.5, and the y value was 1.5. Don't be afraid of decimals in your answer. Actually, a lot of GCSE papers now, the simultaneous equations, they'll come out as fractions. They'll come out as, 11/7 and 19/7, and you think this is madness. Well, no, they're doing that so that you can't just cheat, because they've realized that if they make nice whole number answers, then you'll just guess. You'll just try 1, try 2, try 3 until you find something that works, and that's not maths, that's just guessing. So you can see why if they put in horrible numbers, then it's much, much harder for you just to guess and be lucky. Okay, second question, they're not the same. So we can't do anything unless we manipulate one of them. I'm going to actually change the x's to be the same. So we've got 8x and 4x, so I'm going to multiply this one by 2. I'm going to write it above just to save space when I'm solving it. So 4x is going to turn into 8x minus 2y, and that equals 6. Now, both are 8x, so we can cancel the x's. They're both positive because it doesn't say negative, therefore they must be positive. The signs are the same, so we subtract, and we're going to subtract everything else away. Now, there's a lot of minus signs here, so you've got to be careful. 8 take away 8 is nothing. Big fat 0 around the whole lot. Minus 2 take away minus 3, or take away minus is plus, so minus 2 plus 3 is positive, y equals, and 6 minus 8 is minus 2. Okay, now we know that, we can plug that back in, and we might plug it into this one with easy numbers, 4x minus minus 2, so again, be careful of the negative signs. It is a negative number, so it's take away a negative number, it's the same as add. So 4, that's not very good 4, is it? that's not very good, x. Well, 4x minus 2 is plus 2 equals 3. So take away that 2, 4x equals 1. So we're taking away the 2, therefore x, we're going to divide by 4, and we get a quarter. Not a problem. Now you might want to put it as 0.25, that's fine, but you can just leave it as a fraction. Why not? We do need an equal sign though. Sorry about that. No equal sign, and you're not saying what the value of x is, so you can't get the mark, so be very careful about that. And we could write it as a coordinate, and we'll do it just up here again where there's a bit more space. X value is a quarter, or 0.25. Don't put percentages in, that would be crazy. And the y value is minus 2. Okay, and then the last one has got loads of negatives and nothing's the same, but we can multiply. Now, you might think, oh crumbs, 3y and 2y, times this one by 2 to get 6, times this one by 3 to get 6, but always check both of them. Actually, look, oh, actually, no, it doesn't help, because 2, we've got to times it by 5 to get 10, 5 by 2. So sometimes, I don't know why I thought it was for a second, probably because it's quite late. My brain is addled. If you check, sometimes one of them will convert directly. So like here, we just times one of the equations to get the other, and that was easy, easier anyway. Here we have to times both, but it's always worth checking because one variable might go directly with changing one, and the other might need 2, but in this case, actually, they both would need changing. So we might run out of space here. Let's cancel the x's. So let's make them both 10. Times this top one by 5, you're going to get minus 10x minus, times 1 by 5, 15y, and it equals 50. And the bottom one we're going to double, so again we get minus 10x, which is a good thing. If we didn't get the same, it would have been pointless. We're going to double that, we get plus 4y. And we're going to double that, so 1531. And now the thing we're cancelling, the signs are the same, so we're going to subtract. Now, some people might look at this and go, oh, well, I'm not sure I want to do minus 15 minus 4. You might prefer to do a positive number, take away, even if it's take away a bigger number to get a negative answer. You can do it anyway, as long as you're consistent. So if you're doing the top one, take the bottom one, then you better do the top one, take the bottom one again. And if you change your mind and think, well, it will give me nicer numbers if I go the other way, I mean, in this case, it's not going to make much difference. Then you're going to do the bottom take the top and the bottom take the top again. Must be consistent. Anyway, I'm just going to work down the page. I find that easier. Minus 15g minus g. It's just my bad handwriting. Minus 15y minus 4y gives me minus 19y. And this equals 50 take away 31, which equals 19. Divide by minus 19, and y equals minus 1. If y equals minus 1, we can put that back in up here, and we can say, okay, if this is minus 1, 3 times minus 1 is minus 3, but minus minus, we're basically just adding 3. So minus 2x plus 3 equals 10. Take the 3 off both sides, you get 7. If minus 2x equals 7, then x is equal to minus 3.5. Just dividing the 7 that we're left with here by minus 2, you get minus 3.5. So here you go, the answers are minus 1 and minus 3.5. Now you might think, great, we've got the answers, move on. Please don't just move on like that. It's so easy to make a mistake in all the places we've talked about, the minus signs and getting the equations wrong and not subtracting properly and all this kind of thing. So easy to make a mistake. We should check our answers. Now, if you've got a calculator, even easier and quicker, especially if it's got the equation mode. Get onto the equation mode, type in the values as it asks, and it will just tell you what the answers are. You won't get any marks if you just do that and don't show all of this working out, but you can check whether you got it right. How do we do it manually? Well, all we need to do is check that both numbers fit into both. Now, for this first one, we should have really done them as we went along, but never mind. This first one, in order to solve afterwards, we actually use this bottom equation. So there's no point putting the numbers into that. That's where I got the number 1.5 from. So if I'm wrong, this one will say I'm right because that's where the number came from. Unless I've rearranged it wrong, having substituted it correctly, maybe. But what I want to do is try the other one. So 5 times 2.5 is going to be 12.5. And 3 times 1.5 is going to be 4.5. And I'm taking them away. Sorry, this equation, taking them away. And yes, that does indeed give me 8. Okay, take the 0.5 off, 12, take 4, yeah, 8. So I'm confident. I'm not saying I've definitely got it right, but I'm confident I've got this right because I've put the number back in to the other equation and just checked that I do get what it says I should get. And I could do the same thing on these two questions as well. Take your answer, where did we write it? A quarter and minus 2. We got that from the bottom equation. Put it in the top one. Does it still work? Okay, it's not implausible to think that you would get an answer that works, but that's wrong. Okay, that works for one of them. Because remember, all of the points on this infinite line that go up off the graph forever and down off the graph forever, it could work. So if you've inadvertently worked out the coordinate of that point, yeah, of course, it's going to work on one of the lines because it's on one of the lines, but it's not on the other line. So it's not a simultaneous answer because for a simultaneous answer, we want that point that is precisely the coordinate where they cross over. So if you can't do it graphically, or if you need it precisely, then you need to use an elimination method. There is elimination, no, not elimination. There is simultaneous equations by substitution, and also you can put you can have quadratic simultaneous equations. For GCSE, one is quadratic, one is linear, and you have to do substitution for those. You can't do the elimination method; it won't work. So so we're not finished, but we'll leave it there for today. Ta-ra for now.